Hey folks, so we are finally in the last video of section 8.1. So if you'll go down right after example number 6, we've got example number 7. Now, I didn't hide anything on this one, so just bear with me here. Use it without using the law of sines. Explain why no triangle exists, satisfying where I have an angle that is 93 degrees. Notice that's obtuse. And then I've been given two sides. So this is an SSA triangle, but this is an obtuse option. So what I did, it told me I couldn't use the law of sines, which, by the way, if I did use the law of sines, I would get an error in my calculator. But if I don't use the law of sines, I just simply drew it out. So you notice that I drew an obtuse angle. If this is obtuse, then I know that the side opposite has to be the longest side. Small opposite small, medium opposite medium, large opposite large. Well, side B is 42 centimeters, whereas side C is longer than that, and that is not an option. That can't happen. So what we have is that side B is too short. It's not going to be able to reach in order to make a triangle. And so that's why this triangle does not exist. If I were to look at the reflection question, this is very similar. It says to explain why if I'm given angle A of 30 degrees, side A of 1.5 meters and side B of 4 meters, why is this not a valid reason for having a triangle? Again, if you look at the picture, what happens is that side A is too short to reach. If you were to, now this one does not say that you can't use the law of sines, so back me up on this. If you create a chart and you use the law of sines to find your angle B, what's going to happen is you're going to get an error when you find angle B because the sine of angle B will be larger than 1. So that's why you can't have a valid triangle here. The last concept in section 8.1 deals with finding the area of a triangle. And specifically, we're going to be finding the area of a triangle where we know two sides and the included angle. In high school geometry, you would have used something like 1/2 base times height. And that's great if you know the height. But in this particular case, we don't know the height. We only know two sides and the angle between. And so there is a different option here for being able to find the area. So there are three formulas that are given to you, but they're all three the same thing. Notice it's all three going to be 1/2 times two sides times the sine of the angle that you've been given. So in English, the area is going to be half the product of the two sides and the sine of the angle between. You might ask, why do they use a weird A here? And that's just so that you know the difference between area A and angle A. So that's why they've done that. All right, so let's find the area in this particular triangle picture that we have been given. And so we'll just simply plug into the equation that we were given. Notice this is 1/2 times the two sides times the sine of the angle that was in between. And we'll throw that into our calculator and we'll get 43.1263. Remember, this is area. So my label on this is not just going to be plain old feet, but square feet, because square feet is always measured, or I'm sorry, area is always measured in square units. All right, this wraps up section 8.1.